The Algeciras unit shows competent rock here.
But look at the Al Marchal cores, highly fractured.
We need a flag on this fault plane immediately.
Abort the drill! Retract the legs now, unstable foundation!
Taking the strain now, easy.
Descent rate stable, engaging sonar. Alpha 6, confirm depth reading at your location.
Reading at 200 meters, visibility good.
Roger that, monitoring swell increase.
The seismic risk here at the intersection is concentrated. We need to rethink the foundation design for this specific segment.
The Cameron Sill Plateau is feasible, as shown in yellow. However, these fault zones and scarps in the deep...
Clear the stern! Whoa!
This consolidated layer confirms the bedrock is relatively close to the surface here. Look at the slope on that time-distance graph. We have a clear indicator of the denser formation here. The strike is 340 and the dip is 45 degrees southwest.
Got it, recorded.
Maintain altitude here, pilot. This scarp shows clear evidence of recent movement.
All right, bring it up slowly.
Roger that, hoist is engaged.
Watch the lines, secure it down.
The gravity corer, a large, heavy steel tube, drops freely, impacting the seabed.
Look at the displacement along this fault plane. The gouged material is much thicker than expected here.
Yes, the Al Marchal unit is heavily...
But isn't this?
The data confirms extreme depth and weak ground in this zone.
What are the implications for the foundation design given the activation? The clearance requirement demands these extremely tall pylons over the deep water sections.
Right, that was that.
But that drives up the foundation depth.
As the seismic waves pass through the profile, we see that
The peaks hitverket var full.
The approach bridges connect at the portal structures where it transitions below water.
Right, but the buoyancy system and anchor design for this deep channel are the critical challenges.
The cable wire fatigue under wind vibration is a critical concern here.
And the seismic displacement risk is equally high.
Is invisible in the cavity. The data collected from the existing meteorological stations
Inadequately represents the wind environment at the proposed deck elevation.
This flutter instability observed in the scaled model is a physical representation of the same aerodynamic mechanism that destroyed the original Tacoma Narrows Bridge.
The new truss design significantly improves the flutter onset speed.
That's promising.
But what about the structural efficiency?
The shallow zones get bored piles drilled into the competent rock. The sill zone requires caisson foundations.
We need to ensure the hydrostatic stability during the lowering phase. The flooding sequence is critical.
Agreed.
These results highlight the need for the chosen coating system. We must now finalize the maintenance regime and the associated budget for the splash zone.
The fault geometry is uncertain, but we must move the foundation away from the active trace.
A modest shift here minimizes the impact on the overall design.
This configuration seems to satisfy the stability constraints.
And the environmental impact model shows minimal disruption. The hybrid solution clearly addresses the deep water sections effectively.
And the environmental impact is manageable at the sill zone.
Agreed. This is the concept we move forward with.
The wind loads are peaking.
Seismic response holding in the hinge zones.
We have validation. It survived the combined scenario.
Drop successful, proceeding to next phase.
Roger that. Commencing survey of the profile now.
Adjust 2 meters starboard to align with the target. You are drifting east.
Roger that. Position is confirmed and stable. Good placement.
Make sure that pour is smooth on the edges.
We need more vibration in the center section.
Supervisor says the temperature is holding steady.
Lower another 10 centimeters. Hold it right there. Adjust slightly to the west. Okay, easy now. That's the spot. Go ahead and release the beam.
The camera follows the seabed stabilization work being carried out in the transition zones between the constructed island structures.
Sonar is deployed. We're getting a clean read. Copy that.
Confirming structural integrity on the west side now.
We need the next barge ready in 15 minutes. Keep the flow rate steady on pump 2.
The challenge of connecting Europe and Africa across the Strait of Gibraltar represents one of the most complex engineering undertakings ever attempted.
DP system holding steady at target coordinates. We are within tolerance for the alignment.
Keep those lines clear.
Coming down steady. Watch your spacing.
Lower the jack on the east side by 1 millimeter.
Reading confirmed. We are perfectly aligned.
Excellent work, team. We are within the specified tolerance.
The climbing formwork system grips the outer surface and is jacked upward hydraulically to position the panels for the next pour.
Accelerometer array is secured. Starting cable routing now.
Copy that. Descending to the next anchor point.
Laser alignment is perfect, confirming geometry.
Total station confirms position. You are clear for final set.
The wire reels, carrying high-strength galvanized steel, must remain free of kinks during the unwinding process.
Guide it down slowly.
It's in the chute.
Secure the clamp. Confirmed connection.
The sag is currently reading 45 meters. Apply a correction factor of 0.02 and increase the haul rope tension immediately. Hold it steady.
It's secured.
Quality check complete. Good to proceed.
Launching sequence initiated. Nose approaching Pier 4. Keep monitoring the hydraulics.
All right, bring it down slow. We're almost there. Easy, easy. Contact. Okay, secure the bolts.
The target is 450 kilonewtons. Increase the tension on strand group B by 5%. We are almost there.
Bring her down slowly. Watch the alignment. Looks good from here. We have contact. Secure the connection bolts.
The horizontal angle is verified.
Elevation is spot on, engineer.
Perfect. We are cleared for closure.
Pushing strand 12 now, tension holding steady.
Copy that. Alignment looks good up here.
The microseismic activity is holding steady, well within baseline parameters.
Excellent. I'll update the risk register immediately.
We've got a significant spike here at marker 42. Look at the amplitude.
Okay, I'm moving in to check it manually.
Slow descent on the east side. Watch the alignment.
East side holding steady. We are aligned for the mesh.
Roger that. Secure the sections.
The mitigation is applied in the form of helical strakes spiraling along the cable sheathing, which disrupt the flow of...
The measured deflection here is slightly higher than the model predicted.
Let's cross-reference the strain gauges at P3 before we adjust the model.
Temperature is within the specified range, and the air void content is on target. Maintain the current compaction rate.
The anemometer readings are high. Adjust the VMS threshold accordingly.
We need this operational by sunset.
We have green light on alignment. Proceed with the drop. Copy that. Lowering the segment now. Watch your hands down there.
The closure operation commences with the crane vessel positioned at mid-span, lowering the steel closure piece that bridges the remaining gap between the two deck ends.
Torque it down, snug tight. Copy that.
Alignment check complete. Vertical and horizontal deviations are within tolerance.
Confirmed. Proceed with full bolt installation.
Bolt 42, torque reading 750.
The aerodynamic performance of the structure is assessed under actual wind conditions. With data analyzed,
The measured deflection profile matches the prediction line exactly. The structural analysis is confirmed.
Clearances look good here at joint 4.
Verified. The retroreflectivity on the lane markers is excellent.
Emergency equipment is all state.
VMS updates confirmed. Initiating manual override sequence.
Sequence successful. All systems nominal. Test complete.
Operations, this is the inaugural freight service. The crossing is proceeding normally, over.
Look at the water down there. We are really doing this. It is spectacular. A dream come true for both our nations.
The real-time data confirms the structure is responding as predicted.
Yes, the statistical analysis shows excellent agreement with the design models.
Logging peak response values now. The structural response confirms we are well within the design envelope. The crossing is secure.
With the opening, we've seen unprecedented growth. Our logistics hub is now the central point for moving goods between the continents.
Main cable segment 4. Slight discoloration noted on the protective coating, but the core galvanized wires appear sound, documenting for long-term trends.
Reviewing the daily seismic event catalog, the background microseismicity remains within the normal range. No unusual stress accumulation detected.
What was once an absolute separation between the European and African worlds is now
purpose, educational purpose and informational purpose, using advanced AI tool and human creativity. All concept scripting and storytelling are independently developed to ensure originality. Visuals and animation are enhanced using AI technologies such as View 3, Meta AI and Grok AI, while final editing and post-production are completed using CapCut and other professional editing tools. No external creator content has been copied or used any resemblance to real world environment, factories or processes is purely coincidental. All scenes shown in this video are digitally created and do not represent real footage. This content is produced with transparency and follows YouTube monetization guidance. Thank you and subscribe for more real videos. Manufacturing Factory.